So in this video, I'm going to go through some examples of converting recurring decimals into fractions. Now, in the previous video, I showed you the general process of doing this. We use algebra to do it. The idea being that we set the recurring decimal equal to x, and then we multiply by some power of 10 in order for the recurring part in the decimal to sync up so that they are in the same place, allowing for subtraction to get rid of the recurring bit. That's really the idea here. So let's see that process in action. And I'm going to be going through a couple of examples here at the end, which are a bit tougher because they have a value first before the recurring part kicks in. Okay, so we'll see how we deal with those in a moment. So let's start off with 0.6 recurring. So what we do is we let x be 0.6 recurring. And the idea is that I'm going to multiply this by some power of 10 in order for the recurring part to sync up on the next line. So let's say I multiply x through by 10. So I'll now have 10x. Now if I multiply 0.666666666 all the way through by 10, I'm going to get 6.666666. It moves the decimal point 1 along. So I'm going to get 6.6 recurring. Now the idea here is that what you're looking for is that to the right of the decimal point you will see the recurring part, they sync up, okay? They're underneath one another in the same position. That means that if I was to subtract one from the other, then the recurring part would go. So that's precisely what I'm going to do. I'm going to call the first one 1 and the second one 2. And if I do 2 take away 1, I'll have 10x take away x, which is 9x. And on the right-hand side, 6.6 recurring take away 0.6 recurring, well, the 6 recurring part will go, and I'll be left with 6 take away 0, which is 6. So x will be equal to 6 over 9, which is the same as 2/3. So 0.6 recurring is 2/3. Okay, and that's the same algebraic process I'm going to use throughout these 5. Okay? Right, let's take a look at number 2. Now here we've got 0.52, 52, 52, 52, 52, and so on. So this is 0.52 recurring. Okay, now for argument's sake, okay, look what happens if I just multiply through by 10. Now if I multiply through by 10, I move the decimal point 1 to the right, and I'm going to get 5.25252525. So we now have 25 recurring. And you can see that those two pieces don't sync up. Okay, so multiplying through by 10 was not correct. That did not work out. So instead, I'll multiply through by 100, because that'll move the decimal point 2 steps to the right, and I'll get 52.525252525252, etc. So the 0.52s sync up. So if I call this equation 1 and this equation 2, and I do equation 2 take away equation 1, on the left hand side I have 100x take away x, which is 99x, and on the right hand side the 0.52 recurrings go, and I'm left with 52 take away 0, which is just 52. So x is 52 over 99. Okay? And so that is what I was looking for. So sometimes you might need to multiply by 10, sometimes 100, sometimes 1,000, okay? And so on. Whichever way is going to sync those recurring parts up. So number 3, we have 0.505. So 0.5 505 recurring. So this goes 505, 505, 505, 505 over and over and over again. So probably your best guess would then be, based on what we've done with the first two, I multiplied that one through by 10 and I multiplied that one through by 100. So probably best guess would be multiply through by 1,000 here. So that's going to move the decimal point 3 places to the right. And so I'll be left with 505.505, 505, 505, etc. So as we wanted, the 505 part is syncing up. Let's call that equation 1 and equation 2. Equation 2, take away equation 1. 1000x take away x is 999x. And on the right hand side, the 0.505 recurring will go, and I'll get left with 505 take away 0. So 505. So x is 505 over 999. Now I wonder if you can see a pattern with our results here, right? 0.6 recurring was 6/9. 0.52 recurring was 52 over 99. 0.505 recurring is 505 over 999. Okay, so that's not a fluke. Number 4. Now the difference with number 4 is that we have this 0.5 bit first, then it starts repeating. Okay, so will that change anything? Well, remember we want to make sure the recurring part syncs up. Okay, now if I was to multiply this through by 10, let's say, now although that's in the hundredths unit, if I multiply it through by 10, you will get the recurring part matching up, and I'll show you what I mean. The decimal point is going to move one step to the right, so we'll have 5.2222222. So you might be thinking, well, I could write it as 5.2 recurring, and then the 2 recurring part isn't matching up. But you could write it like this. I mean, that would be an unconventional way of writing the recurring, but that means the same thing, and now you've got the recurring parts matching up, and you could do it that way. Okay? If you want to do it by 100, because it's in the hundredths position, well, nothing's stopping you from doing that. Okay? So that works out as well. I think in the grand scheme of things, you'll probably want to keep the fraction as easy to work with as possible. So in this scenario, I think 10x will just do. So 5.22 recurring. We'll call that equation 1 and that equation 2. So if I do equation 2, take away equation 1, on the left-hand side we've got 10x take away x, which is 9x. And on the right-hand side, the 2 recurring part will go, and I'll have 5.2 take away 0.5, which is 4.7. So x is 4.7 over 9. Now we don't want a decimal in the numerator, so I would multiply top and bottom by 10, so we get 47 over 90. Okay, so the multiplying through by 10, multiplying through by 100, in some cases there are multiple avenues you could go down. In this scenario, multiplying through by 10 was fine. Let's try number 5. Naught point 812121212, etc. Okay, now if I was to multiply this through by 10, I would get 8.121212, etc. And you can see, although usually you would put the points here for what's repeating, you could write it like this in an unconventional way, really just to highlight that the 1, 2 recurring here and the 2, 1 recurring here are not matching up. So multiplying through by 10 is not a good idea here. That doesn't help me. So in order to make sure it matches up, I would multiply through by 100. So I would get 81.2121212, etc. And again, you would usually put the points there to identify that it's 2, 1 that is repeating, but just to aid us, I'll put the point there so that we can see that the 1, 2s are matching up. So if I do equation 2, take away equation 1, we'll get 100x, take away x on the left-hand side, so 99x. And on the right-hand side, the 1, 2 recurring part will go, and I'll have 81.2 take away 0.8, which is going to be 80.4. So x will be 80.4 over 99. Multiply top and bottom by 10 to get rid of the decimal in the numerator. 804 over 990. Now that fraction can be simplified. Top and bottom are even, so we can divide top and bottom by 2. So that'll be 402 over 495. Okay. Now, can that be simplified any further? Now that's divisible by 3 and that's divisible by 3, so dividing the top through by 3 we're going to get 134, and dividing the bottom through by 3 we're going to get 165, and that's as far as we can go, I think. So 134 over 165. Okay, and so that is how we can convert recurring decimals into fractions.